Hey guys, just doing another video for you. We're going to be starting biology today, and today we're going to be taking a look at the microscope. Um, there is a lesson before this on organelles, so what I'm going to get you to do is take your time right now, flip to the microscope lesson. We have changed this lesson quite a bit. This year you're actually very lucky because we're going to be taking out all of the math from previous years. So there were a couple of formulas that we took a look at. We decided against putting them in this year because you're going to learn them in grade 11 anyway. So we're going to go just straight with the content for you. So just to the teacher who's in today, if you could please just pause the lesson whenever the students need to copy, that would be great. So we're going to start off with this. We're looking at rules for scientific drawings to begin. In the coming days, we're going to be doing a couple of labs involving microscopes, and a lot of those are going to involve making some scientific drawings. So now you can't just like take your pencil and start sketching an image. It doesn't really work like that in science. There's some very serious rules that you need to follow and need to make sure that everything is done appropriately. So like this page here is like going to be key for you. So all of this stuff, I'll never ask you to memorize this, but I will ask you to refer to this all the time. So when you're doing your diagrams, you need to make sure that you make all of this a priority. So you need to make sure that at the end you check and that you've hit all of these things. So when you're doing your scientific drawings, they should all look exactly like this. And in the coming days, we're going to have some time to kind of practice that. Okay, now because we took out some of the math, this lesson now becomes very, very easy for you. All you're going to really need to know is how to label the different parts of the microscope. So we will start right off at the top. So the very first thing is our eyepiece. So obviously this is what you look through. This is called our ocular lens. So you can see it referred to as either of those two names, but this will be the thing that you're looking through. This thing actually has a built-in magnification. So even without using one of our lenses down below, this thing has a magnification of about 10 times in itself. So next thing we're going to take a look at is our body tube. And after our body tube, you're going to see two things. You're going to see two different kind of knobs. You're going to see a big knob and you're going to see a very small knob at D. So the big knob is what we call our coarse adjustment knob. And the one at D, that small one, is the fine adjustment knob. Now these two things are really different, obviously. So the coarse adjustment knob, really what this is going to do is it's going to send your actual microscope, your body, like up and down. So it's going to physically move this thing up and down. Generally what happens is once you get your image set, you want to like take your hand and never touch that coarse adjustment knob again. From there, after your microscope is in the right position vertically, you're going to take your fine adjustment knob and now you can start tuning that. So you can move that right or left. And that's actually going to change the focus of your microscope. So the coarse adjustment knob is the first thing you're going to use. The fine adjustment knob is going to be after that. Okay. To transport the microscopes, we use letter E. We use our arm to carry these things. So don't carry it by like the ocular lens or the lenses or anything like that. The F is our revolving nose piece. This is going to allow you to select which of our lenses you'd like. So we're pretty lucky our microscopes actually have 3 lenses on them, which means we can take a look at our object in 3 different kinds of magnifications. So we have 3 objective lenses. We refer to them in really 3 separate divisions here. We have our low, our medium, and our high. And on our microscopes, every single one of our microscopes has the exact same magnification for each of these, the low, medium, and high. So our low is always going to be 4 times, our medium is going to be 10 times, and our high is going to be 40 times. Good stuff. You do well to remember that. Okay, next you're going to take your slide, which is what your specimen is placed on, and then you're going to put it on letter H, which is our stage. Okay, so our stage is this like giant black platform here, and then there are some like little clips you can see that are held in by like these screws. Over here, those are called our stage clips, but stage is really what you need to know there. All right, our last two, or two of our last three, are very closely linked. Our condenser lens for J, and our diaphragm for I. So the condenser lens is important because it's the thing that's actually going to direct kind of how our light focuses on an object. And the diaphragm is kind of what opens up to see how much light we want to focus on an object. You will not be doing any really setting of that. That's going to probably just be left at the default, which is going to be perfectly sufficient for our purposes. And then K is just going to be our light source. So obviously to see our specimen, we need to make sure it is illuminated. That's kind of what we're dealing with there. Okay, and the last thing, which doesn't have a letter, but we should put it in, is the base. So you can expect to see this diagram on your upcoming quiz, which I'll talk about once we go through the first lesson tomorrow, but you can expect that quiz to probably be on Tuesday. All right, so I would really know how to label this diagram like perfectly well. Okay, something to think about. The other thing I would know is how to explain each of these parts, and in case you weren't paying attention in how I did it, we're going to take a look at what they all mean right now. So, very simply, let's see if I can do this. Is that going to work? For our eyepiece, so our eyepiece is the part you look through. So this is actually going to be the thing you put your eye through and you can actually see what's going on. It also has a magnification, and our magnification of our eyepiece is 10 times. So just by looking through that, you're already seeing the image 10 times as big as it really is. Okay, good stuff. Next, we have our body tube. So our body tube is really just responsible for holding everything together. So it holds the eyepiece and our revolving nose piece. Good stuff. So it holds our eyepiece and revolving nose piece together. This thing is really just there to link everything, and will also really provide some stability for a microscope to make sure nothing's falling apart. Revolving nose piece we talked about already. It just allows you to select which lens you'd like. So it rotates to select a lens. And remember, we have 3 lenses that we take a look at here. So our objective lenses, we have 3. We have our low, we have our medium, and we have our high. So our low, medium, and high. And if you remember from last slide, low is 4 times, medium is 10 times, and high is 40 times. Now, I said there isn't going to be any math, and really there's not. There's one very small, not really even an equation, that we're going to be taking a look at. But what I want you to realize is when we're taking a look through our objective lenses, so if we're looking at like the high lens, for instance, we're not actually seeing that object at 40 times. We're seeing it at a far greater magnification than that. We'd actually be seeing it at 400 times magnification. And you're thinking, okay, but like, how does that make sense? It says 40 times right here. And that's true. But remember, you're not just looking through that objective lens. We're also looking all the way back up here. Very first thing you look through is our eyepiece. So you need to combine those two magnifications. You need to say, okay, I'm looking through the eyepiece and I'm looking through my objective lens. So it's the 10 times times our 40 times. And that's how we get to our 100. But we'll talk about that math in just a second. Okay, arm, this is really just used to carry our microscope. Okay, our stage is what the slide sits on. So you're going to put your slide on the stage. It's an ugly one. And to make sure this slide doesn't slide off, you get slide off. You get it? Did you get it? It's because it's a slide and sliding off. It's a pun. You get it? Okay. We will use stage clips. So this will secure our slide in place. Okay, and now we only have a couple of more things here that we're going to take a look at. So next we have our light source, and our light source just basically provides light to So here we're going to get actually some light to make sure we can take a look at our object. And then we have two more things related to our light. So next is our condenser lens. And this is going to take that light and start focusing it or directing it. So it's going to direct light to our object. So it's going to take this really wide beam of light and turn it into a more focused, concentrated set of rays. And our last thing to do with light is our diaphragm, and it just controls how much light we have, basically. So how much light is going to reach our object. Okay, our last two. So the first one is our coarse adjustment knob. And big thing here, our coarse adjustment knob, this is our larger knob. And the other thing, you are only going to use this with our low power lens. The reason you only use it with the low power lens is because this actually will end up moving our microscope, so the stage and the objective lens are going to get closer and closer and closer together. So it's actually going to move things up and down, up and down, up and down. And if you have a high power lens, that lens is actually much bigger than our low power lens. So if you have that high power lens on and you start moving this gigantic knob, it's actually going to move the slide up until it actually hits and breaks your slide, because it's going to contact this very large lens. So that's why we only use it with the low power lens, and on top of that, it's just way easier to focus stuff. So we're going to use it with our low power lens, and here's what we do. So it moves the tube up and down. So it's going to move the tube up and down, and it's really to bring objects into focus. The trick to using microscopes is to use the coarse adjustment knob. Oh my goodness, what is this? This isn't what I wanted. You're going to use this thing first. Once this thing is set, you will never touch it again. You're done. Because now you're going to turn your attention to the fine adjustment knob. The fine adjustment knob is the smaller one. And the key here you are only going to use this thing. Once your coarse adjustment knob is set, you like its position, everything is perfect, then you can start using the fine adjustment knob, and then you can start kicking your thing into medium or high power. But you need to get your coarse adjustment knob set first, then never touch it again, and then you're just going to move to the fine adjustment knob. So this is going to be used basically just for our medium and high power applications. So we're never going to actually, well, normally you're not going to use this to help you on low power. So for low power, you're going to use coarse adjustment knob, going to get that set. If you need to investigate the thing in medium or high power, you're going to start by flipping your objective lens to medium, then turn your fine adjustment knob and to get that set, and then you can go to high and do the same thing. But you're not going to touch your coarse adjustment knob after. We'll have lots of time to practice that next week once we start taking a look at some of our microscope drawings. Okay, good stuff. How to handle the compound microscope, just don't drop it and we'll be fine. Using it, I will go through all of this with you, so do not worry about that. Now, magnification. Here's how this works. If you remember our magnifications from the slide above, what is the magnification of each of these things? Well, we said our eyepiece always has a magnification of 10 times, and then our low had a magnification of 4 times, and then our medium was 10, and our high power was 40. But we said when we look at the specimen, it's actually not those measurements that we're really interested in. What we're interested in is the total magnification, which means we have to take a look at everything that we're looking through. So to look at a specimen, you don't just look through a lens, you also have to look through that eyepiece too. So here is really the only formula in biology, and it's not even really a formula at all. It's our magnification formula. Basically what you're going to do is you're going to take a look at your eyepiece and multiply it by your objective lens power. And that's it. So for instance, we'll do the first one together. So for low power, our ocular lens will always have this magnification. In this circumstance, our magnification will be that 10 times. So it says up there, our magnification for our ocular lens is 10 times. So what's the objective lens on low? We said, okay, that's 40, or sorry, 4. And then if I want my total magnification, I take my ocular lens, multiply it by my objective lens, so 10 times 4 gives me 40 times. For medium, my eyepiece didn't change. I still have this exact same eyepiece that we have from before. So I have 10 times. My objective lens now, medium power is going to be 10, so 10 times 10 is going to be 100 times magnification. And then for high, exact same thing. My eyepiece, my ocular lens, still at 10 times for our microscopes. And my objective lens is now at 40, so my total magnification is 400. So all we did is multiply ocular lens times my objective lens. Okay, so this is where you're going to catch a break, because we will not be doing our field of view, which people generally don't like, and we're not going to be taking a look at this formula either, so you don't need to worry about that at all. So the only thing you need to do, one thing I would like you to do is just make sure you can convert from millimeters to micrometers. So maybe if you're on this page right here, in this space we're not going to worry about the math here, so I'm just going to give you something else to consider. So if we have a measurement in millimeters and I need to go to micrometers or micrometers, they have this fancy symbol. It looks like a U, but it's actually called mu. Like mu, like in Pokemon, like number 151, mu. It means micro, and micro is way smaller than our millimeters. So if we want to go from millimeters to micrometers, you're going to multiply by 1,000. And if I ask you, okay, something is 100 micrometers, and I want to go to millimeters, obviously you're going to reverse that, and you're going to divide by 1,000. My God, sorry. I have no idea how loud that was. Oh, sorry. Oh, I might be dying. All right. So in this question, we have this measurement here, 2,000 micrometers. I need water. Oh, my God, I'm so thirsty. What do I do? There's nothing around. Oh. Okay, fine. All right, let's get this done. All right, 2,000 micrometers. So if I ask you to convert that into millimeters, what do? Well, we say, okay, micrometers to millimeters, we divide by 1,000. So I take that, and I could say, okay, 2,000 micrometers divided by 1,000 would give me 2 millimeters. Okay, so in your homework, you should be able to convert from micrometers to millimeters without any issues whatsoever. So your homework. There are a couple questions here that you cannot do. So let's take a look at the ones you cannot. So we're going to eliminate number 4. And, oh yeah, we're going to eliminate number 6. So really all you have to do, this is going to take you 15 seconds, is just 1, 2, 3, and 5 is what we're looking at here. And then once you are done that, just at the bottom of the page, or the last page, types of microscopes. So it says use page 8 and 9 of the text. You don't have your textbook, but you do have the LMS, and I have uploaded in under content the pages that you'll need to complete this. Okay, so there's a lot of really cool microscopes out there. Just make sure you take a read and kind of complete this chart. The solutions to everything are up on the LMS as always, so really all you're responsible for is 1, 2, 3, 5, and then getting this done. And remember, everything that you need to complete this is under LMS, under content. All right, I will see you guys tomorrow. Ciao.